The question says that a compound microscope consists of an objective lens of focal length 2 cm and an eyepiece of focal length 6.25 cm separated by a distance of 15 cm. How far from the objective should an object be placed in order to obtain the final image at the least distance of the distinct vision, that is 25 cm, and at infinity? What is the magnifying power of the microscope in each case? Now here we have been given a compound microscope of which objective has a focal length of 2 cm and the eyepiece has a focal length of 6.25 cm. We have to find out how far from the objective should an object be placed. Like we have to find out the value of u objective in the case VE, that is the image formed by the eyepiece is at minus d. D is the least distance of distinct vision, that is 25 centimeter, and the second case is that VE is equals to infinity, that is the image is forming at infinity, which is good for relaxed eye view. Now we have to also find out what is the magnifying power of microscope in each case. We have to also find out the value of m. Now we will use two formulas in this question. The first is lens formula, that is 1 by V minus 1 by U equals to 1 by F. Here I have represented VFE and FO as a focal length of eyepiece and the objective respectively, and subsequently U and V has been also represented with the subscript of E and O, as E as the eyepiece and O as the objective. Now let us move towards the first case where the image is forming at the least distance of distinct vision, that is 25 centimeter. So we know that in a compound microscope an object is placed over here in front of objective. Now this will form a virtual image between these two lenses, let us say over here, and this virtual image will be treated as a virtual object for eyepiece, and this eyepiece will form the final image, which is somewhere magnified. Now we have to find out the value of u naught in both the cases. So in the first case, the least distance of distinct vision, the image is forming, that is the final image, VE is forming at minus d. So we will use the lens formula for the eyepiece. We have been given the value of VE over here, that is minus of d, that is minus of 25 centimeter. So using the lens formula for the eyepiece, we have got 1 by VE minus 1 by UE is equals to 1 by FE. So d here 1 by V is minus of 25 centimeter. Now 1 by UE is equals to 1 by 6.25. We have been given the value of FE, that is 6.25. And since it is a convex lens, so FE is going to be positive. Now solving for this, we have got a value of UE as minus of 5 centimeter. So it means that the object for the eyepiece should be at minus of 5 centimeter, or with proper sign convention, the object should be here with a distance of 5 centimeter from this pole of this lens, that is 5 centimeter. Now for the image to form at minus d, the object should be here. Now for this lens, what is the distance between this lens and this image? So the image by the objective is going to be treated as the object for this eyepiece. So if the object should be at here, that is at 5 centimeter from the left of the lens, then the image formed by the objective should be at 10 centimeter on the right side of this lens. So V naught, that is the image distance for this objective, should be equal to 10 centimeter. So V naught or the VO is equals to 15 centimeter minus 5 centimeter, that is 10 centimeter. So we have got a value of FO. We have been given the value of FO, that is the focal length of the objective, that is 2 centimeter. We have to find out the value of UO, that is the object distance from the objective. So using lens formula again, we have been given the value of FO and VO, and we have to find out the value of UO. So solving this, we have got a value of U as minus 2.5 centimeter. So the solution of first case is here, that is if the object is kept at 2 centimeter from the lens of the from the left of the objective, then we will get a final image at a distance of 25 centimeter from the left of this eyepiece. Now we have to find out the value of magnification. So magnification in this case, we know the formula for magnification is given by VO by UO multiplied by D by UE. So here VO is the image distance from the objective and UO is the object distance from the objective. D is the distance of distinct vision and UE is the object distance from the eyepiece. So we have all the values over here. We will substitute it and we will get a value of 20x. So when the image is forming at the least distance of distinct vision, then we are getting the magnification power of 20. Now in the second case, the question was final image at infinity. That is, the final image formed by this eyepiece is going to be at infinity. So we know for image to form at infinity, the object will be placed at the focus. So UE, that is object for the eyepiece, is going to be minus FE, and we have been given the value of FE, that is 6.25 centimeter. Focal length of the eyepiece, that is 6.25 centimeter. So let us find out the distance of VO. Distance between the two lenses is 15 centimeter. So VO plus UE, that is, let us understand with this diagram. VO plus UE. VO is the image formed by the objective. VO is the image formed by the objective plus UE, that is, that image is going to be the object for the eyepiece. This will always be equal to 15 centimeter because the distance between the lens is fixed, 15 centimeter. So using this, we will find out the value of VO, that is the image distance from the objective, and this will give us a value of 15 minus 6.25, that is 8.75. Since this is from the right of the objective, so this will be positive. We will put it in the lens equation again, and for finding out the value of UO, so for solving this question, we will get the value of UO as minus of 2.59 centimeter. Now we have got the data for the second case as well, that is when the image is forming at infinity. So using the formula, same formula for magnification, that is VO by UO into D by UE, we will get a value of magnification as 13.51 x. That is, the magnifying power is less when the image is forming at infinity as compared to when the image is forming at the least distance of distinct vision, that is 25 centimeter. I hope you understood this question. Thank you.